Yeah, today's our topic is here routing. So, can anyone explain the difference between what is the difference between L2 and L3 in OSA model? What are the difference between L2 and L3? What is L2 and what is L3? Layer 2 and layer 3. And what are the difference between to them? Anyone?
So layer 2 in OSI model is called data link layer and layer 3 is called network layer. And in layer 2, we use devices like switches, and in L3 we use devices like routers. So layer 2 is basically, if the devices want to communicate each other which are in the same network, then layer 2 comes in play. Whereas if the devices which are in different places or different areas, the two pieces wants to communicate, then we need routers. So different subnetworks.
Fine. Good. Apart from that, anything else?
And in layer 2, we call, like, the terminology is frames, and in layer 3, it is packets. The data is transmitted using frames and packets in layer 2 and layer 3.
Good. And anything else? Anyone can.
So layer 2 manages
They,
node-to-node communication using MAC address, whereas layer 3 handles packet routing between networks using IP address.
yeah.
Yeah. Yes, Bhavana. Go ahead.
Yeah, I just wanted to say that point, which he mentioned. Yeah. So they communicate using IP address and MAC addresses.
Mm. Okay. What is the difference between routed and routing protocols? And in which layer it will be work?
Routed protocols are like IP protocols, IPv4 and IPv6, whereas routing protocols are OSPF, BGP, and so on.
Okay. Those are the examples. And what we'll do with the basis of routed and routing protocols?
Routed protocols, it will be doing the logical addressing, whereas routing protocol will do the path determination. So which path to choose?
Good. Fine. And MLS, multi-layer switch. In which layer it will be work? Multi-layer switch.
Layer 3.
Only layer 3?
Uh, like the traditional layer is like layer 2, and we can also use layer 3 for routing.
For routing. It will be work in both layers,
Yeah,
L2
it
and
works in both
as well.
layers, layer 2 and layer 3. Yes.
So by default, L3 switches, multi-layer switches, ports are by default, those are act as like layer 2 only. It means we have to configure the no switch port. Then only it will be act as L3 port. So we have to use the command that is no switch port. Then only it will be work as like L3 port. So here by default routing is disabled in L3 switches. By default routing is disabled. So we have to enable the routing with the help of IP routing command. So then only the L3 switches, sorry, L2 switches work as like L3, means multi-layer switches work as like L3 routers routing. Then only they will perform the routing, and if you are not using the no switch port command, then we cannot assign the IP address also. Fine. Clear? L2 and L3 differences. Nitin,
Yeah,
can you explain about the router? What is router?
router is an device between communication between one to one and in a simple way. And it's like it holds the traffic between the two devices. So,
Okay, you mean to say a router will work host to host. It means within a network, a router will work, right? Is it right? You mean
yeah,
and switch where it will work?
sorry.
Switch also
Which
work
works
within.
in the network, right? In the network, like PC to PC, like some networks, like a certain span of networks, like it can't go like far through networks, like it has a limitation. So switch works in that conditions.
Then what about the router?
It can hold a large amount of networks, like and deals with that actually with the
Okay, between the network.
yeah.
But if we want to communicate multiple network, we need a router.
Router.
Fine.
Yeah.
Fine. Good. So we'll start our new topic, that is routing. So routing, it's a important topic, guys. So listen properly. So here I am taking one router and in a different router, actually switch before that switch where it will work within a network, within the organization, within a network. It will actually switch what it will be to broadcast the information. Whenever the PCs are originated some traffic, it will broadcast the information within a LAN. So if we want to broadcast, stop this broadcast, so we have a VLAN. With the help of VLAN, single will break this broadcast in single broadcast domain into multiple broadcast domain. So if we have VLAN 10 and VLAN 20, it will be break this broadcast. These all are L2 protocols and L2 it will be work. So now move to the L3. L3 means it's a LAN network. Actually, local area network. If you want to communicate at branch 1 to branch 2, means one location to branch 1 to branch 2, at one geographical location to another geographical location, branch 1 to branch 2. So then we need a some requirement, that is ISP. It's a ISP, Internet Service Provider. So internet, with the help of internet only, we can reach to one geographical location to another geographical location. So if ISP is not there, so we cannot able to reach one location to another location. So that is the reason, if here we have a multiple network, whenever we are reaching the WAN, so wide area network, so LAN to LAN reachability with the basis of WAN only, wide area network. So without a WAN, we cannot able to communicate at one location to another location. This is the location. We have one PC here, one branch or one another PC here. If you want to communicate together, so requirement is here. ISP. In that ISP means WAN wide area network. So here we have a multiple networks. So in between multiple networks, if we want to communicate, so we need a router. So router basically what it will be do? It will be transfer the traffic basis of L3 from whichever the getting a sources like MAC base. In this layer, MAC addresses will work, and here in L3 we have a routed and routing protocols. Those are IPv4, and routed protocols are IPv4 and IPv6. These are the IP assigning, logical IP you mean to say, are IP assigning with the will assign the IP addresses, and it will be carry the user information. So now move to the routing protocols. Here routing protocols will be path determination. So if we want to communicate one location to another location, here I have given the only one ISP. If we have the multiple ISPs, we have in between we don't know, because one geographical location to another geographical location, multiple routers are available. In between, multiple routers are available. In this ISP, you don't know how many routers are there. Those routers will be performing routing in only. Even though not only in the WAN area network will use the routing protocols. If we have the multiple brand in our organization only, for example, in our organization, we have the multiple branches. In our organization, multiple departments. So, for example, account department, sales department, and any business department, any management department, something. So we have a different departments. This is a IT departments. This is a network departments. So every department most they will use different network. They will not use same VLAN as well, same network as well. They will use definitely different network IP addresses. Different network means here you can assume like 192.168.10.0 for this network. Here we have the 254 IP addresses, and in this department we are using the different network, that is 20.0/24, and for this department it's an account department, and this one is a HR department, and this one is a sales department. Every department will use different networks. So here we have the in our within our organization also we have the multiple networks. So these many networks, it won't possible to communicate with the without L3 device. It won't possible. If you want to communicate inside also, these devices, these networks, so routing is required. So routing is required inside also. Inside organization also, routing is required. So because if we are not using the routing protocols inside the network, so how they will communicate a router, how they will transfer the traffic. So basically router will maintain the routing table. These routers are maintain the routing table. With the basis of this routing table only, they will send the traffic. So they will send the traffic. So here we have a multiple users in account department. They want to communicate HR department. So in this HR department, having this PC having the 10.10 IP address, and this HR department having the 20.10 IP address. So how the packet flow it will happen? First, they don't know the MAC address. Switch, maintain the MAC address. First, it will be send the packet to source and destination IP address. First, he wants to communicate the destination, that is that IP address is 20.20.10. So what will happen? Source source IP address is here 10.10 and it will be give the L2, it's a L3 packet. It will be moved to the L2 first. So data will be flow from top to bottom and bottom to top. So it will be sending the message and giving the reply likewise. So source MAC address is, for example, this is A having PC A and this PC having B MAC address. So source MAC address is like A. So it will be reach router. Router will maintain the routing decisions and routing table. If this route information, the router have, then only the router send the packet to unicast one-to-one communication. Switch will do multicast, but router will do only unicast. Whichever the traffic is coming from whom, that router will send to that traffic that person only, not it will be sent to another persons. So basis of routing table only it will be sent. For whom this routing is packet is came for 20 PC. The destination is 20.10. So MAC address is B. So before that, here this router will have the MAC address is within a network only. This interface MAC address only this router will get. If this MAC address is C, then all time C will be give the reply up to here only within a network, within a LAN side only MAC binding entire thing will be work. So this MAC will be here, it will be get. So whenever you check the switches in MAC table, it won't get the another network MAC addresses. So it will be get this interface MAC address. For example, F0/0. So it will be get the same MAC address. This is a packet flow and they will get basis of, they will communicate basis of the routing table. How we'll check the routing table? Basically, don't worry, we'll check entire thing. Enable, show IP route. It's a routing table. This is a routing table. Based on this routing table only, the router will work and router will be sent the traffic. Traffic will send basis of the routing table. We'll discuss these things in lab. Just I'm showing what is routing table. So before that, some brief about a router. A router is a device which is used to make communication possible between two different devices with different network addresses. So router device maintain routing table. So router device maintain routing table. Here we discussed router will maintain routing table to make communication possibility. Sorry. Router device maintain routing table to make communication possible and for the best path selection to reach the destination. So here we have a two different networks. So this is a 10 network, 10.0 network and /24. It's a 20.0 network. So we have the multiple path in between. So router will select the basis of routing table. It will select the best path. Which one is the best path? It will be select and transfer the traffic all time basis on that path only. So ports of router device work only full duplex mode of communication. The router devices, whichever the ports are there in router, it's a router. So how we'll check the router interfaces? Before the show IP interface brief. So fast Ethernet 0/0, we have a port and fast Ethernet 0/1. Two interfaces we have. So 2 ports. So show interface fast Ethernet 0 by 0. So you can check here, it's a full duplex. Router interfaces are full duplex only. The speed is 100 Mbps. So router interfaces always full duplex. What is the mean by full duplex?
It can send and receive data at the same time, and half
Simultaneous.
duplex cannot do simultaneously.
Great. So router works on network layer in OSA model. It will be work in layer 3. It's a layer 3 device. So some components of router: RAM, NVRAM, flash memory, ROM. So it's a temporary memory actually. RAM means temporary memory of device. And if you want to check the configuration of RAM, so whenever we are configuring the in router, whenever we are doing the configuration, so if you are not saving that configuration with the help of write command or copy command, copy running configuration to startup configuration. So it it is like the entire configuration will be available. It is temporary only. If the router shut down, if the power issue, if power down, then the configuration, entire configuration will be gone. Which configuration? That is show running configuration. This is the running configuration. So entire configuration will lose if you are not saved. That is available in RAM only. So what about NVRAM? Whenever you save that entire configuration, that is like permanent memory. It will be stored in permanent memory. So that configuration is available in startup configuration. That is, we call it as startup configuration. If you take one new device here, any device, just power on that device. So if whenever the running configuration is temporary memory actually. So IP interface brief, which IP interface IP. So we have gigabit ports, okay, fine. So show running configuration. We have not done anything, but these all are stored in RAM. So if you want to check the NVRAM configuration, that is startup configuration, show startup configuration. Nothing is there. If you save something, do here config t and assign IP address for some interface gigabit 0 by 0 by 0, and IP address is 192.168.10.10 and 255.255.255.0, and no shutdown, use no shutdown command. So startup. So still we cannot see the configuration, but we can see that is that configuration is running configuration. It is not stored in. So we some configuration we did here, but that is available still in RAM only, random access memory only. So if we want to store this entire configuration, it will be stored in NVRAM. So it is a memory of router in simple words. So how will store? So we have a two options: store in memory. So where it will be stored in NVRAM. So with the help of this command also you can write, or simply write also, or we have a one more option, that is copy running configuration, some devices will accept this also, and some devices will accept. So copy running configuration to in where we have to store. So we have a option that is startup configuration, means it's an NVRAM. So startup. Likewise, also you can store the configuration, save the configuration. We have two options. One is write command, another one is copy running to startup. Likewise, if you are store here also, here it will ask like if you want to give any file name. So if you want to give any file name, it will be give, you can give. Otherwise, it will, by default it won't take. Whichever the running configuration, by default it will take. Likewise, so if you want to check, show startup configuration, now it will get whichever we configured, entire thing will be given. So that is NVRAM. So flash memory. In flash memory, IOS, Inter-Network Operating System. So in our laptops also we have a operating system. Likewise, in network device, every network device like routers, switches, firewalls, whichever the network devices we have, every network devices, they have the operating system. That is, we call it as a inter-network operating system. That is, we call it as a inter-network operating system. Basically, where it will be stored in flash memory. How we'll check? With the help of show flash command. So basically, the files are bin file. So it will be stored like any name, ABC, or any iOS version, any switch device. If for example 1900 series switch is there, so based on that it will be stored. So but the file name is .bin. Check here. So yes, this is a bin file. This is our iOS actually. So this is a storage available bytes used. So .bin. So here you can check the series of router, ISR router. This one is the ISR router. So 4300 series, universal K9 dot 16 dot 06 dot 04. This is a version. It's a version. So the iOS stored in flash memory. If flash memory is crashed, then you cannot able to access, you cannot able to open the router also. And ROM, hardware. So we have a hardware also. So it work for post power on self test. It means ROM will check the all hardware components of the router devices are working in proper way or not. The hardware components are working proper way or not. If every router having the devices in physical view, you can check here. So this router having the fan also. In between we have a fans, and we have the some slats. These are the actually we call it as a LAN slats. These all are the LAN slats. So these slats are working properly or not. Who will check? ROM only will check. Entire thing. These sockets are working properly or not. These fans are working or properly or not. These ports are working or properly or not. Entire physical or hardware components are working properly or not. Who will check? ROM. Entire thing will be check ROM. It's not like RAM, flash, and NVRAM, etc. This is all about router components and what will we do with the help of routing. Any doubts?
Can you just tell the command that is used for storing the configuration. So one is write command and another one.
Okay,
So I think it's copy running configuration.
I'll give you a chart. I'll give you a chart. Save that.
Oh, okay. Yeah.
So copy running configuration to, and we have a where it will so whichever our running configuration is there, basically. So that configuration, if you want to store in pen drive, so just to plug in your device, which device, router, then give, it will be get USB something, then give likewise name, whichever you want, abc.bin file. Likewise, you can store that. Otherwise, we have a options here by default option, flash memory, you can save the configuration. But flash memory, we won't save those configuration. Flash memory, I already iOS is available. So we'll store in NVRAM. So we have a option here, startup configuration, startup configuration. So this is a command. Apart from that, any doubts?
No, it's clear.
Fine. Good. Now move to the routing. So basically, routing, before that, we'll discuss something here. So as we discussed here, if I want to communicate branch to one to branch two, here if we have a three path. My source is here and my destination is this one. If I want to reach my source to destination, this router having entire routing information. So if we are taking here 11.1.1.10 IP network to connect this router, and here we have a different network 2.0 network, and we have a different network here 3.0, and here we have a 4.0. These all are the network. This router maintain every routing route information, path information. These all are the path. First path, second path, and third path. This router maintain entire path. If one path is goes down, so we have another path. In this case, whichever the shortest path, the router will stored in primary memory, in routing table. Whichever having the best path, that will stored in routing table. RIP table, that is we call it as a routing information base. Whichever the best path are available, it will be stored in RIB, routing information base. So here you can check in this case, which one is the best path. So which one is the shortest path? Here we have it in between 1, 2, 3, 4 and 4 hops. And here we have a 3 hops, and here we have a only 2 hops. 1, 2, 3, 4. Here we have 4 hops, and here 1, 2, 3 hops, and here we have 2 hops, 1, 2. Now guess which one is the best path?
2 hops one.
2 hops one, because we here we have a less hopes, so it will be select the router This is the best path, and it will store in routing table. In routing table, it will be stored. So forwarding packets from one network to another network, choosing the best path from the routing table. It will be stored forwarding the packets from one network to another network. It will be choose the best path from where in this routing table only. So routing makes possible for two or more different network to communicate with each other. So with the basis of only routing only we can communicate two or more networks. Routing table consists of only best path routes in every destination. So here we discussed. So router will maintain. So whichever the best path, router will maintain that path only in routing table. How will check? Show IP route with the page show IP route command will check the routing table. This is the command. Don't forget. So basically, three types of routing we have. Three types. Two we can configure here. We can configure the three ways. So first one is statically we can configure, and default both are the same. So statically we have to manually we have to configure. So what about the dynamical? So in this case, statically, whenever we are configuring, so each and every path we should have to know from router 1 to router, whichever the router from source to destination. This is a 5 you can take. So router 1 to router 5, each and every path we should have to know. Then only we can configure the static routing. If we don't know the path, then we have a default routing. If we know each and every path, then only we can have easy to configure it. If we don't know path from source to destination, so we can configure easily 0.0.0.0. It's a global IP address. It means whenever you are configuring 0.0.0.0 and subnet also 0.0.0.0, so entire IP addresses, whichever the IP addresses, it will be private or public. Yes, you can communicate it. It means it's a global IP address. All host, these all are the host, no networks. So network means for example, net 192.168.10.0. So in between, this is a network bit, this is the network bit, and this one is the network bit. This is the host bit. So host bit means it's a 0. So if you have given the like this network 255.255.255.0, how many hosts are available? How many hosts are available? That many hosts only you can communicate. 254 hosts are available. But whenever you configured it is, so you can communicate entire networks, global networks, entire networks. So that is default routing. So we'll move here three ways to configure the routing. That is static, default, and dynamic. So what is static routing? In this type of routing, we manually define the routes in a routing table of router device. So we have to manually assigning the IP addresses. We are manually creating the routing table. In simple manner, in simple way, we are manually creating the routing table. For example, IP route. So whenever you see S statically, it means you configured as a statically, manually you did. Whenever you know the destination IP addresses, destination networks, when you know the destination networks, if you know this destination network as well as in between how many networks are there, entire topology you should have to know, entire topology. If you don't know the entire topology, so you cannot able to configure it. So if it is small size of organization, mid size of organization, easy to configure it. If it is a big size of organization, no, we cannot able to configure it. So we don't know, manual mistake, human mistakes will be happen. So that is the reason we cannot able to communicate. So if we know the entire topology, then yes, we can configure it. And best path selection is taken by the network engineer only. So who will take best path selection? Network engineer. Manually we have to configure it. In case of static routing, if you are configuring the static router, so we have to configure the best path also. Mandatory need for the destination network ID. We have to know the destination network ID for every destination, and every destination routing has to be done manually. So manually we have to configure, and it is used for the small organization. That is what we discussed. It is for the used for the small organization only. The one more thing, it will be used AD value, administrative distance value. So every routing protocol having the AD value. So AD value basis only will define the, will select the routing. It will be to select the routing. So AD value, whenever you will see the AD value is 1, that is static routing. So what is AD value? Basically AD value is a every routing protocol, and every routing protocol having the AD values. So with the help of AD value, it will be select the best path. So we have a OSPF routing protocols also AD value, EAGRP also having routing value, and RIP also having routing value, and BGP also having routing AD value. Entire routing protocols having the routing AD value. With the basis of AD value only, which routing protocol it will be select. So for that, I'll give the overview. I'll give the brief on that. So first we'll check here best path selection. So how the routers will select the best path? First of all, it will be select the longest prefix. So for example, this router having the IP address, for example, 11 dot 11 dot 1 dot 1 dot 0 slash 24, and this routing, this path having 11 dot 1 dot 1 dot 0 slash 30, and 11 dot 1 dot 1 dot 0 slash 24. So first it will be select the best path, whichever the best path basis on the longest prefix. This is the longest prefix. It will be select the best path, this one, and it won't go to the another one. So second is AD value. So AD value, it will be give the least AD value, whichever the having the least value, whichever having the least AD value, least is best here. Least is best here. So static having AD value is here 1, and for example RIP having the AD value here 120. So RIP having AD value, static having AD value is 1, RIP having AD value is 120. So which one is having the AD value least, that will be elected as a best path. So then if AD value also match, for example, if both cases we are using the 24 only, so it will be tie. It will be tie. Then it will be moved to the AD value. So first it will be check longest prefix. If longest prefix is matched, then it will be moved to the AD value. If AD value also match, here we are using static, that is AD value is 1. Here also we are using static, AD value is 1. Otherwise we are using here RIP 120. AD value is 120. Then it will be moved to the whichever the least AD value. One is least, one is the best. So it least is best here. So it will be moved to the this path. It will be select. It will be stored in routing table this path. If AD value also match, then it will be moved to the metric value. In metric value, so every routing protocol having the different metric calculations. So RIP is hop count. Even though we'll discuss whenever we are discussing, I am giving the brief here. So RIP having hope count here, which least hopes is best. So here it will be one hope. So it will RIP is select, this is the best path. If when we configure here also RIP, and here also RIP, and here also RIP. So 120, 120, 120, and prefixes also match. So prefixes also match, then it will be moved to likewise. So if metric is same, here also one path. From source to destination, only one path is there. So if source also match, then it will be moved to the ECMP, equal cost multipath, which it will be take the decision of basis on the equal cost multipath. So here you can check the best path selection on router device. So longest prefix, then lowest AD value and metric value, then load balancing, that is ECMP, equal cost multipath. So this is all about the static routing. Static routing having the AD value is 1. Now there we have two ways to configure it. First it will be configured here. So this is a configuration thing. So first move to the router and use the IP routing and destination IP address, whichever the we know the destination IP address, destination subnet marks, and our router exit interface. Our router exit interface or next hop IP interface. Next hop means exit interface is this one. Exit interface is this one. Next hop IP address is this one. Two ways to configure the static routing. First one is with the help of exit interface, and otherwise we will configure next hop IP address. This is the next hop IP address for this router, and exit interface for this router. So there is no overhead. So easy to configure, and advantages here. Easy to configure and no bandwidth uses also. So manually we are configuring. That is the reason bandwidth also no use. So it will be no use bandwidth also, and it is more secure also. It will be secure because each and every router network engineering, and we are manually, yes, administrator is manually configuring. So it is more secure to compare to other routing protocols. And it will disadvantages used for the small network only, small organization network. It is not feasible in large networks. It is not, we cannot use for the large networks. Each and every network has to manually configure. So each and every network we have to manually configure. So administrator must really understand the inter-network and how each router is connected in order to configure routing correctly. So we should have to know the entire topology. If we don't know the topology, we cannot configure it. So any changes in the network, internetwork has to be updated in all the routers. So we have to manually, if any changes occurred in network topology, for example, here we configure this is a path. So if this path goes down, then that is the issue only. So manually we have to choose another path. And if this path also goes down, we have to manually choose another path. So it is a tricky. So we have to know the entire thing. So if it is small network, yes, we can easily configure it. And if any network goes down, so we have to configure again and again. So this is all about the static routing. So now default routing. So default also manually we are configuring when we don't know the destination IP address. Whenever we unknown the destination address, so where we'll configure it? Internet. And it will be reducing the reducing the routing table also. It is reducing the routing table. So whenever you configure the routing, default routing, that is 0.0.0, so single route will be available in our routing table. I'll show you in routing table how it will look like. So if we have the 100 routes are available. So for this route comes only as a static 0.0.0.0. Here it will be shown star. Star means default. Destination like this will show like 0, and via one IP address it will be show 11.1.1.2 via whichever the traffic is coming from router 1 to router 2. It's a exit interface. This is a path of this one 11.1.1.2. So this entire networks are available in this route. Simply the source and destination we can easily communicate from this likewise. So whenever you don't know the destination, that time we'll configure the default routing actually. It will be reduce the size of routing table. Everyone understood what is the default routing and static routing? And we'll configure same thing here. Here also same thing. Destination is 0.0.0 and destination subnet marks also 0.0.0 and next hop IP address and exit interface. Two ways to communicate, same thing. And advantages. There is no need to know destination IP address. Yes, we no need to know the destination IP address. We need to advertise the directly connected network, whichever the directly connected network. So if we don't, we know the directly connected this network. If we know this directly connected network, so how many 100 prefixes you have? Yes, we can advertise to entire globally these networks. So this is not secure also. And administrative work is reduced, mostly all the work is reduced. Only one command we can configure it. So used for the large organization, neighbor router exchange routing information and build the routing table automatically. The routing table also build it automatically. This is easier than using the static and default. Dynamic. Easier. This is easier than using the static or dynamic. And disadvantages. And distance vector protocol types of dynamic solving. Disadvantages like it is unsecure. So we are configuring like 0.0.0. So only disadvantages is not secure. This is not a secure protocol. Not secure. So if we configured at our LAN location in between, why it is unsecure means, so this is my LAN. Here we have multiple branches and those branches having the unique networks. So if we connected in between ISP, so if we configured here like in this interface as a 0.0.0.0, so here we configured 0.0.0.0. So here man in middle attack came. He connected. So he can reach out if whichever network he want, yes, he can reach out. So that is the reason it is unsecure. Even though we'll configure in different in this interface, but that time we'll apply the NAT, network address translation. So and we have the firewalls also. In real time, we'll configure it. I'm not saying like we won't configure the default routing. We'll configure it, but we have a secure for firewall also and NAT also for that. Got it? Any doubts? We'll move to the configuration. If you don't have any doubts, we'll move to the configuration part. This is
All
all
the
about.
topics were clear for me, except for the types of static routing. So exit interface, there were two types, so that was not clear to me. Yeah, the
Okay,
exit
this is
interface.
configuration part. Okay, I'll we'll discuss in lab. These things we'll
Okay,
discuss in lab.
okay.
Here I have given the syntax how to configure the protocols. Here I have just mentioned the syntax.
Uh, yeah, I
Don't
mean,
bother.
just the type. So what is exit interface and what
We'll
is
check
not?
in lab.
Okay, yeah.
I'll show you in lab. Apart from that, anyone have any questions?